Okay, so here is basically 4.5, which is solving polynomials. This is just the day one of a 2-day solving set of notes here. And so today we're going to focus on just the basics of solving and kind of just to get the process down for using some basic equations here. And then the next day we'll get into some more complex type of problems. So the first thing I want to just show you is number 2 here. This is a problem where, up until today, really, we would be able to solve a problem like this. So we would first move, the 60x over to the other side. So I have 20x to the third plus 80x squared, and then plus 60x equaling 0. The reason I say we should be able to do this one is because we just got done factoring polynomials, and so this should feel very comfortable here looking at this and going, okay, I think I can do this. Oh, sorry, and that's 80, not 8. 80x squared. So the first thing that, logically you would think to do here is see that all of them can be divided by 20 and that they all have an x. So what we're going to do here is we're going to just simply divide everything by 20x to take out a GCF. And whenever possible, you want to try and do that just to make the problem a little bit easier. So we're going to take the 20x and put it outside. When you divide, you end up with x squared. And then when you divide there, you end up with a 4 and then an x. And then when you divide the last term, you get a 3. And the x's cancel, so that's it. And so now it looks even more familiar because you're like, oh, well, hey, that's a quadratic, and I know how to factor a quadratic, or I can solve a quadratic. And so from here, you can say, whoa, I could just do my, my a times my c. So I could go, okay, a times c, 1 times 3 is 3. My b right here is 4. So what numbers will multiply to be 3 and add to be 4? If you guessed 3 and 1, then you'd be right. 3 and 1. 3 and 1. 1 times 3 is 3, and 1 plus 3 is 4. So it works. So I'm going to just shrink this up just a little bit so I have a little bit more room without going into the other problems here. And now I can put this into factored form using my dead cartoon eyes, x's, with the factors of positive 3 and positive 1. I can't forget the GCF I originally factored out earlier as part of the problem here as well. Now, the only thing that's different here when you are solving, and this again should look familiar because we did this in the quadratic unit, and that is how to solve a quadratic that's been factored. And so most kids remember, oh, wait a minute, I need to set, all of these equal to 0, including the value that's here on the outside, because that also has a variable. Anywhere where you see a variable, you have to set those equal to 0. So I'm going to set these equal to 0 here. 20x equaling 0, x plus 3 equaling 0, and x plus 1 equaling 0. And then when you solve for x in each one of those, you end up with x equaling 0, x equaling negative 3, and x equaling negative 1. And that should be, your 3 solutions there. Remember that whatever the exponent is here will tell you how many solutions you should have. And so I should have 3 solutions, and I do have 3 solutions here. So that was really nice because the problem was factorable, and I know how to factor and take GCFs out and solve. So the question is, well, what happens when the problem is not factorable? Now, in doing all these notes earlier, I kind of went through and I was like, you know what? I don't really like any of these notes for basic type of problems here. So I know we're going to go off script here a little bit, and we're actually going to just make up a few problems here so I can show you what you're supposed to be doing. So if you want to scroll all the way down to this blank space that we have at the bottom of the page, I'm going to write down a couple of problems to do so we can practice what we're doing today. So the question is, the problem we just did, that's a problem that's factorable, and we can do those problems because we've already been taught how to do those problems. But the question is, and I'll call this question 1, when I have a problem like this, x to the third minus 7x squared plus x plus 5, and that is, well, what do I do if the problem is not factorable? And so this is where it presents a challenge, because I know there's 4 terms, and so you may say, well, you could use grouping. Well, you can't exactly use grouping here because the problem isn't able to be grouped. Not all 4 term things can be groupable, I guess you could say. So this is a problem where it's not factorable. And so how do we do this? So what we need to do is we need to use our graphing calculator. Now I'm going to go ahead and pull up the graphing calculator that I have online here. And so let me get back to the home page, go to my calculator. Not what I wanted. Calculator, there we go. Start. Okay, so there I have my graphing calculator, and so what we need to do is we need to put the equation into the graphing calculator to allow for the calculator to maybe give us a solution. So we're going to go to y equals, and we're going to plug this in. So I have x to the third. By the way, the exponent button is just above your division button there. That takes you up to the exponent. And then you can type a 3 since there is no x to the third button. And then minus 7x squared plus x plus 5. So once we get that in there, we can use what is called the table of values to see if the calculator can give us any of our solutions. And so if the table of values is where the graph button is. So if I hit second and graph, it's going to take me to this table of values here. And this is a nice place to be because we can have the calculator tell us any solutions. If you remember anything about what solutions are x-intercepts. And x-intercepts are where your y is 0. If you think about where a graph crosses the x-axis, at that point it crosses, the y value would be 0 there. So we can find solutions to these questions by simply looking at where y is 0. And if you look there in the middle, you'll see in the blue column, you'll see a y value of 0 where x is 1. And so what that tells us is that that's one of our solutions. That's an x-intercept. So we know that one of our solutions is 1. So I know that one of my solutions is 1. Now, I know that because of this exponent here, I know I'm going to have 3 solutions, but the calculator only gave me 1 solution, and that is 1. So how do we find the other 2 solutions? Well, from here, you have to run it through synthetic division. And you'll see why we do this in a minute, but right now we're going to use our solution and go through synthetic division. So we have a 1 for the x to the third, a negative 7 for the x squared, a 1 for the x, and a 5 for my constant. Now once we go through synthetic division, 1 times 1 is 1, negative 7 and 1 is negative 6, negative 6 times 1 is negative 6, 1 and negative 6 is negative 5, negative 5 times 1 is negative 5, and I get a remainder of 0. Now that should happen, by the way, if you're thinking like, hey, that's cool, you should get 0 as your remainder here because you're using an actual solution, and when using an actual solution, you should have no remainder since this is an answer, so you shouldn't get any leftovers. So that's that should happen. You should get 0 at the end. And so now what I have, since it started out as x to the third, my answer will go to x squared. So this gives me x squared minus 6x minus 5. Now, here's the reason why we did that. Because we could not solve this quadratic. I mean, we used the calculator to find one of our solutions. We have really no way of solving this algebraically. So what we can do is use one of our solutions, run it through synthetic division to turn our cubic, our x to the third, into a quadratic that we can actually solve. We can solve quadratic equations, all quadratic equations, using the formula, the quadratic formula. So what I'm going to do here is just kind of show you the quadratic formula. But we can use the quadratic formula to help us find those other two solutions. So I'm going to plug everything in here real quick. Let's change colors a little bit here. So I have x equals opposite of b plus or minus the square root of b squared. Negative 6 squared is 36, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times a, and so 2 times 1 is 2. So when you do your discriminant, which is what you're supposed to do first, you end up with 9, or I should, not 9, you end up with, I don't know where I was going with that. It's not 9, it's 56. So you end up with 6 plus or minus the square root of 56 over 2. Now this can simplify. 56 goes to 7 and 8. 8 goes into 4 and 2, and 4 goes into 2 and 2. So I have 2's that are pairs, but I have a 2 and a 7 that are unpaired. So this will become 2 radical 14, because 2 times 7 is 14. So my final answer will be 6 plus or minus 2 radical 14 over 2. Now you could reduce that if you wanted to, but this is going to serve as your answer. Now I'm going to tell you that you now have all three solutions. Let me erase these. I have one right here, and I have 2 right here. If you're like, how is that 2? Well, remember that there is a plus or minus, meaning that there's 6 plus 2 radical 14 over 2, and then 6 minus 2 radical 14 over 2. And so you have actually 2 solutions here. 1 here and 2 down here, and that is how we find all 3 solutions. Okay? So we're going to try one more. Okay, so let's look at one more version of this, and see actually get this from another question here. So let's look at that, and we'll go do it right here. So another one that we're going to do is negative 2x to the third plus 5x squared minus 3. And so, and then equals 0. And so again, we're going to put that into our graphing calculator and find one of our solutions. Sorry, I'm moving around here. Okay, y equals, I'm going to plug this in, negative 2x to the third plus 5x squared and minus 3. So there you go. And then we go to our table of values again, so second and graph, and that takes us to our table of values here. And so it looks like we have one of our solutions there is 1. So I'm going to use 1 in my synthetic division. So negative 2 for the x to the third, 5 for the x squared. Notice how we don't have an x term this time, so it'll be 0, and then a negative 3 for our constant. We do synthetic division here, bring down our first term, which is negative 2. Negative 2 times 1 is negative 2. 5 and negative 2 is 3. 3 times 1 is 3. 0 and 3 is 3. 3 times 1 is 3. Lots of 3's here, but we do get that 0 at the end, which tells us that we did that right. Now again, the reason for this is because there is no real algebraic way of solving polynomials if the polynomial itself is not factorable. So The way we get around that is by using our calculator to give us one of the solutions, and then using that solution in synthetic division to get it down to a quadratic. So what I have now is negative 2x squared plus 3x plus 3. And so from here, now I can solve this because it's a quadratic, and I can use quadratic formula. So I'm going to go ahead and do that now. Quadratic formula, x equals negative b. I have that. Yeah, there you go. So negative b, it's over there. And that is negative 3 plus or minus the square root of b squared. 3 squared is 9 minus 4 times a, which is negative 2, times c, which is 3. And that'll all be over 2 times a, which 2 times negative 2 is negative 4. So again, we're going to do our discriminant first. So 9 minus 4 times negative 2 times 3. And so we get negative 3 plus or minus the square root. If you do 9 minus 4 times negative 2 times 3 and hit enter into your calculator, we do get what I believe here is 33. I got to make sure here. 2 times 8, 24, 30. Yep. You end up with 33. And then over negative 4. What you're going to find here, though, is that the square root of 33 is not simplifiable. Can't be simplified. So that actually is just your answer, because 33 will break down into 3 and 11, but then there's no pairs that can be found from there. So I have my solution, or 2 of my solutions there, 1 of my solutions here, and that is all 3 of my solutions. So that's how all these go. Pretty much the same process for any type of polynomial we are solving. And so next class we will look at these and look at some variants of this. So